Hey guys, and welcome to a new exciting lecture. It's Miss Miklos with today's lecture, which covers an Algebra 1 concept. But we are going to be implementing a few things we've learned throughout this particular year. So we are going to have to recall how to factor. That's kind of the big thing of this chapter, is dealing with factoring. And so I would definitely recommend, if you are someone that struggles with factoring, make sure you are coming in and seeing me for additional help. So today specifically, we are working with multiplying and dividing rational expressions. And let's talk about this real quickly. We know rational means a fraction. Okay, a number that's rational we can write as a fraction of integers. A rational expression, we know an expression does not have an equal sign. So it's going to be a polynomial over a polynomial. So it's a fractional expression that we are going to be working with. And the biggest thing we're going to be doing today is simplifying rational expressions. So the question that comes into mind is, when is a simplified expression in simplified form? And the answer, which I've written out nicely for you here, it is in simplified form provided its numerator and denominator have no common factors other than plus or minus 1. And I want to talk for a moment about this term common factors. Often when we see the word factors, we immediately think of factoring, which is an accurate depiction of factors, but that's not the only way we see it. We also have used factors in a factor tree when we just have numbers that we are multiplying together. So the major thing for us to know is factors really means that I'm breaking down something in terms of multiplication. So if there are any factors, once it's in terms of multiplication, we need to cancel them out. So to do our problems today, in order to simplify, the very first thing we're going to do is get it into terms of multiplication, which means factor. And then we're going to cancel out our common factors, which crossing stuff off is always nice. It's fun. We can pick a fun color and do it. So let's get into number 1. This is a pretty straightforward question. And by far the biggest thing that I see students want to do is they see this problem and they go, oh, x squared, let's just cross them out. Oh, there's -4, -4, and let's cross those out. And that is completely wrong and incorrect, and I'm going to undo those right now. The reason why that is incorrect is because x squared is connected to 4x and 12. This is a trinomial. It is not in terms of multiplication. X squared minus 4 right now is in terms of a binomial. It is not in terms of multiplication. So when we see addition and subtraction signs, I know I need to factor first. So the first thing that we're going to do here is think, how can I factor x squared minus 4x minus 12? So first thing I would do is look for a GCF, but I don't have one. So then I need to think, what factors of -12 add up to be -4? And that would end up being -6 and +2. Just a reminder, we can double check if we factored correctly by foiling this out or doing our inside and outside terms. So is -6x plus 2x equal to -4x? And it is. Now we're going to go ahead and factor our denominator here. So I have x plus 2 times x minus 2, because x squared minus 4 fits our difference of squares pattern. Now if we look at our expression, everything is in terms of multiplication. So now we can look and see if we have any common factors that we can cancel out. So I'm going to go ahead and try and find a fun color here for us to use. Or I'm going to be boring and just use yellow. And I notice these x plus 2's are exactly the same, so I'm canceling them out. And I have x minus 6 over x minus 2. Now once again, a lot of people are now tempted to cancel out these x's, but this is not in terms of multiplication. In fact, x minus 6 is a binomial. I can only cancel this out if there's another x minus 6. These are connected. They go everywhere together. And back when I was teaching Algebra 1, I used to tell my students to think about that one couple that they know that they're friends with that only hangs out with each other. And I'm sure you guys know that couple. You might even be that couple. But regardless, x and -6 are like that couple. They don't separate. They only leave if they leave together. So in this case, I do not have any common factors. So my answer is x minus 6 over x minus 2. Number 2 looks completely different because if we explore this particular problem, we don't see any addition or subtraction. That means that we just have monomials here, and it is already in terms of multiplication. So that means I can cancel stuff out right away. And there's really 2 ways we could do this problem. We could cancel stuff immediately, or we can do what I'm about to do, which is multiply straight across and then reduce. Okay, and we can do either way, it does not matter. So if I'm multiplying the numerator together, 5 times 6 is 30. X squared times x cubed is x to the 5th. Yes, we need to remember all of our exponent stuff from a few chapters ago. Y times y squared is y cubed. Now, moving on here, in our denominator, 2 times 10 is 20. X is all alone. Y cubed times y is y to the 4th. At this point, I'm going to look at each one individually and reduce. So 30 divided by 20 would be 3 over 2. I can battle these x's, and the numerator is going to win by 4. And when I battle these y's, the denominator is going to win by 1. So my answer would be 3x to the 4th over 2y. Now that we've seen this a little bit, we're going to get into some tougher stuff here. So this time I have 4 things that I need to look at, and I only have one monomial, so I know I need to factor these other 3. So starting with 4x minus 4x squared, I'm looking for a GCF, which is 4x. And when I take that out, I'm left with 1 minus x. In the denominator, I do not have a GCF, and I need to think what factors of -3 add up to be 2. And that would be +3 and -1. Next, x squared plus x minus 6. I believe that's going to be +3 and -2. And then I'm left with 4x. So this is factored completely. Everything's in terms of multiplication. And if we look, I have some x plus 3's that we can cancel out, and I have 4 x's that we can cancel out. So it appears that I'm left with 1 minus x times x minus 2 over x minus 1. And these 2 terms look very, very similar. In fact, you may remember from factoring a while ago that we call terms like this opposites. And when I have opposites, we want to go ahead and factor out a -1 out of one of these 2 parentheses. Okay, because if I factor out a -1, it's going to make these equivalent to one another. So I decided to choose the numerator here, and 1 minus x, when I factor out a negative, the 1 becomes a -1, the negative x becomes a positive x. And all of a sudden, I notice that -1 plus x is exactly the same as x minus 1. So I'm canceling those out. And quick note, when we cancel things out, what are we left with? And I think sometimes we have a common misconception that we think it's 0 because I'm getting rid of everything. But I'm really left with 1 because I know the ratio of anything over itself is always equal to 1. So here I'm left with negative the quantity x minus 2. And when I distribute that, I have negative x plus 2. So this is definitely the type of problem I would expect to see on a quiz or a test, where we do have to go a step further and figure out that whole concept of opposites. Okay, so here's number 4. We have x plus 3 over Ooh, this looks scary. 8x cubed minus 1 times the quantity 4x squared plus 2x plus 1. And then I don't know why I have a little squiggle there, but that's okay. So I want to focus here on 8x cubed minus 1. This was what we call difference of cubes because these are both perfect cubes. And we learned that difference of cubes and sum of cubes are really the same idea. So here we have a cubed minus b cubed, and our pattern was ab, a squared, a times b, b squared. And we had to remember the word SOAP, which SOAP stood for same, opposite, always positive. So this pattern does not go away. We still need to have that memorized, and we're going to apply it to 8x cubed minus 1. So if you guys don't know this, make sure to write that down in your notes and commit that to memory. So now back to the problem here. X plus 3 I cannot do anything with. We said we're using difference of cubes on 8x cubed minus 1. So I need to figure out, first of all, what is my a value and what is my b value. So our a value is whatever the cube root of 8x cubed is, which would be 2x. Our b value is the cube root of 1, which is 1. So this pattern is going to go a squared, a times b, b squared. And our signs go same, opposite, always positive. And something really nice just happened here, because when I rewrite that other trinomial that we have, and I'm going to write it over 1 because it's in the numerator, we notice that these are exactly the same. So even though they are giant trinomials, if they're the same, we can cancel them out. So I'm left with x plus 3 over 2x minus 1. And there's nothing else we can do here because I do not have any common factors. At the beginning of this lesson, we said it was multiplication and division, and this is the first time we're seeing division. And do not fret. All division means is that we are going to multiply by the reciprocal. Okay, so it is exactly the same as what we've been doing, except we have an additional step of changing this into terms of multiplication. So now I have 5x over 3x minus 12 times x squared minus 6x plus 8 over x squared minus 2x. So I'm going to go step by step here. I know 5x, there's nothing I can do. 3x minus 12, I always look for a GCF first, and I can take a 3 out, and I'm left with x minus 4. X squared minus 6x plus 8, I know that's going to be x and x. And negative 4 and negative 2 will work because negative 4x minus 2x equals negative 6x. X squared minus 2x, I can factor an x out, and I'm left with x minus 2. So if we look at these, I know my x minus 4s are going to cancel, my x minus 2s are going to cancel, and there is more we can do, but I'm just going to show us for a second that we are currently left with 5x over 3x. And I want to discuss why is this different from x plus 5 over x plus 3. And if we take a look here, these are both binomials. We do not have any common factors. Here, these are both written as monomials, so we do have common factors. In fact, I can cancel out those x's, and I am just left with 5 over 3. Let me recross this out so we can see it all. So sometimes we will end up with just a rational number as our answer. Okay, most of the time we will still have x values, but the whole thing, once again, simplifying simply means I am getting rid of all of my common factors. I wanted to look at number 6 because I think this can be tough once again to factor. I noticed we have division, so I'm going to do two things at once here. I'm going to factor and I'm going to change it into multiplication. So I'm going to look at 6x squared plus 7x minus 3, and I notice I do not have any greatest common factor there. So I'm going to have to use opposite of FOIL. And I know the ways that I can get 6x squared would be 6x and x, or possibly 3x and 2x. And I'm going to try that first. Next, I need to think, what are possible factors of -3? And I'm thinking 3 and 1, and one of them is going to be negative, one of them is going to be positive. So why don't we do 3x minus 1 and 2x plus 3? Now to double check this, I need to check, is 9x minus 2x 7x? And it is. So I know that I'm good. Here in the denominator, 6x squared, there's nothing we can do. Now here's where I'm going to do two things at once. I know instead of dividing by 2x squared plus 3x, it's going to be times 1 over, and I am going to factor this now. I notice we have a GCF of x. When I take x out, I'm left with 2x plus 3. So now this is factored as much as I can. I notice I have 2x plus 3's. So in my numerator, I'm left with 3x minus 1. And in our denominator, I have 6x squared times x, which is 6x cubed. I cannot cancel these out because the 3x is dating the -1. They're connected. They go everywhere together. So 3x minus 1 over 6x cubed is our final answer. And our last example of the day, hooray. Looking at this, once again I see we have division, so I'm going to go ahead and write this as x over x plus 5 times 3x minus 5 over 1 times x plus 5 over 9x squared minus 25. So notice when we have division, I'm only flipping whatever fraction is immediately behind that division symbol. So now looking at this, we're going to try and factor, and I notice x, x plus 5, 3x minus 5, x plus 5, those are all good. But 9x squared minus 25, I can do more with it. In fact, to me that looks like it fits difference of squares, so I'm going to write 3x plus 5, 3x minus 5. And rather than rewrite everything out, I decided to just cross that off and write it in those factors. So now I notice I have x plus 5's in common. I have 3x minus 5. So I am left with x over 3x plus 5. So hopefully this is really coming back to you guys from Algebra 1. Key thing is I need to know how to factor in order to simplify these rational expressions.